Enclosed underground car parks require ventilation to remove pollution. Different regulations apply in different countries. Standards are available offering specific guidance in design of impulse ventilation systems for enclosed parking. Ducted systems, and more recently, impulse ventilation systems are used to provide pollution ventilation, and may also provide for emergency smoke clearance. Impulse fans assist the distribution of air within the parking area to ensure no stagnant areas, especially at adult head height. To demonstrate the operation of an impulse ventilation system, we show an enclosed underground parking area. We see axial jet fans and centrifugal induction fans to induce air movement towards the exhaust points. Other locations, types and quantities of impulse fans could be used with different results. However, an experienced ventilation engineer may be able to target the optimum solution. For pollution ventilation, typically a CO sensor may activate predetermined impulse fans to distribute fresh air, and extract fans exhaust this pollution to atmosphere. Thus, with addressable sensors, only the fans in the prescribed zone need to be activated to reduce pollution. Diameter from 315 to 630 millimeters. Fully reversible impeller for airflow in both directions. Impeller is cast aluminium alloy. 2 motor versions, 1 or 2 speeds. Officially approved to EN 12101-3 at F400, F300 or F200. 3 models: Thrust 50, 75 and 100N. Backward curved centrifugal impeller in galvanized steel and balanced in accordance with ISO 1940-1 G6.3. Casing in galvanized steel. Complete fan assembly independently tested and approved in accordance with EN 12101-3 at F400 or F300. Adjustable pitch aerofoil blade, cased axial flow fans designed for smoke extract in fire conditions and certified high temperature. Available in short and long casings. Corrosion resistant. Suitable for horizontal or vertical mounting installation. 2 motor versions, 1 or 2 speeds. In an emergency scenario, for smoke clearance, activation of an appropriate sensor may operate alarms for the evacuation of the parking area and immediate operation of appropriate extract fans. If applicable, following an appropriate delay for evacuation, predetermined impulse fans can be activated to assist the movement of smoke towards the extract point. All fans running at appropriate speed to provide design ventilation rates. Thus, smoke and heat may be removed from the parking area. Impulse ventilation may also offer enhanced smoke control to assist evacuation and firefighter access. Fans would continue to run until failure or deactivation by firefighters. Computational fluid dynamics (CFD) tools are available to enable the ventilation engineer to visualize behavior of air, and indeed fire smoke, to review the location of these impulse fans to optimize the solution. Typical CFD analysis may include evaluation of air velocity to determine if any areas of stagnant air. These may be shown as colored contours indicating relative air velocity. This figure shows air velocity at breathing height with pollution detected in all the car park. No significant stagnant air, deep blue color, appears. This analysis is important to ensure ventilation of the whole area. This figure also shows the centrifugal induction plume discharging down as required due to the car park geometry. Further investigation is required to ensure there is no significant air recirculation to optimize pollution removal. Analysis of local mean age of air in normal pollution ventilation shows no significant recirculation. Fresh air enters at inlets, collects pollution and is discharged at exhaust points. But more importantly, recirculation may not be acceptable with emergency smoke clearance. This figure shows air velocity in emergency mode, when smoke and heat is detected in the car park. No significant stagnant air appears. Increased extract airflow is required in fire emergency mode, and we see higher velocity from inlet points to exhaust points. Analysis of local mean age of air in emergency mode shows no significant recirculation of potential smoke. Impulse and extract fan operation has been modified to reduce recirculation. Fresh air enters at inlets and impulse fans induce air and smoke movement towards exhaust points. Recirculation is not desirable for emergency smoke clearance. This animation shows velocity streamlines flowing from inlets to exhaust points, providing air movement throughout all the car park area. A poor design of impulse fan system with acceptable air velocity may have unacceptable local recirculation of air and smoke. In emergency scenario, for smoke control, operation of the fans may be similar but sized to accommodate sufficient air movement and control of smoke. However, not all car parks and systems may be suitable for this enhanced facility. Appropriate CFD tools also assist competent ventilation engineers to evaluate impulse fan solutions for pollution, smoke clearance and the more complicated smoke control requirements. Of course, all CFD analysis can be verified with on-site testing. S&P is a global company providing solutions for ventilation in many diverse applications, especially for enclosed car parking applications. Many car park projects worldwide have ventilation provided by S&P. Experience gained from many years of providing ventilation solutions means that S&P has the experience to provide impulse ventilation for enclosed car parking.